Hey, Tapiel. It's been a minute. How have you been? All right, so we're good. Let's get into it. Just look for a question out there on the interwebs. Should I look at physics? I shouldn't look at physics, but I'm going to do it. Oh, wait. Well, this is really just calculus here. What is this whole... So we have velocity, and we want total displacement, which means we just integrate, and we don't have to worry about signs, because they're not asking about distance traveled. Displacement is just the final ending position minus the beginning position. So you really just, I mean, even here you don't have to worry about negative values anyway. But it's the area in the curve. You can get this geometrically, and I'll do it like a trapezoid, I guess. You could also make like a right triangle from like this spot here over to the corner and up, and then worry about the rectangle separately. But you can do it in one step with the trapezoid. So this top part of the trapezoid is 10, the bottom part is 60. So it's 10 plus 60 over 2. No, yes. Which is 35. Divided by the height, which is 5. 35 divided by 5 is 7. That makes no sense. If you're going 10 meters a second at least for 5 seconds, what did I do wrong? You're gonna expect to travel at minimum 50. A plus b over 2 times height. How is that wrong? What happens if you just... Okay, what happens if you do it the triangle way that I was saying before? The bottom is 5. The side is 60 minus 10 is 50. So 1/2 base times height is 1/2 times 50 times 5. So 25 times 5 is 125. Plus the area of the rectangle on the bottom is 50 is 175. How does the area of the trapezoid not work? Am I misremembering the formula? A plus b, where a and b are the parallel sides, over 2 times h. 60 plus 10 over 2 is 35. Oh, times h. I was dividing by h. That's why. What's 35 times 5? Please tell me it matches. 175. Okay. See if someone beat me to it. Okay, good. Ooh, my humidifier. 1 second. There we go. Okay. There's not a whole ton to explain with this one, I guess, so we'll kind of asking them how they got to their answer, and we'll see if they reply back, and we can maybe give them a bit more information if they want to engage a bit more on that question. But if not, that's like kind of a quick enough one. I don't mind just saying the answer to. Calculus-based physics. How do you mathematically simplify the first half of 4.2.1 to the other? I mean, I guess let's look at this one too. Oh. Okay, this is a... It's definitely calculus-based physics. I got what was promised. They're asking how you go from this diagram to that equation. Or they're asking how you go from this left side to that right side. Like, maybe I could figure out the math part. Oh, looks like there's some differential stuff that's happening. Ooh, yeah. Hey, Bode. What is this fancy T? Membrane tension per unit length, okay. I'm doing good, Bode. How about you? So is this saying, I'm trying to figure out if I can like at least figure out the math behind this and not worry that much about the physics of what's happening. So TdZ, I guess, is the horizontal tension per unit length. So it's a force per length. So I don't know. The net vertical force from opposing TdZ. So the horizontal force generates vertical force? Oh, I was lurking on Zach's stream. I saw that there's some kind of back and forth, but I wasn't really able to follow that closely. Oh, yeah, I don't know how to do this problem. That is an answer, though. Sorry that you got into an argument like that. Recalc half angle. Let's see what's up with this one. Oh no. Oh wait, never mind. I thought this was gonna be some weird like measuring things in degrees and like arc seconds or whatever the decimal degree thing is called that I still don't really understand, but here we're fine. So if cosecant of x is equal to 2, that means sine of x is equal to 1/2. But then you need to apply a half angle formula. Which one would you want here? Oh, yeah. I think I see what's happening. We need to do it. I'm surprised no one else has answered this one. Maybe because they didn't put where they're confused. Students said thanks. They see where they went wrong. Awesome. Okay. So yeah, let's work this one out. Because you can just solve for x explicitly, and you could actually just calculate this the old-fashioned way too if you wanted. So yeah, we're gonna need to use like this one. Do we? We might need to use this one actually. Okay. Let's try and work this one out. Oh, 90 is less than x is less than 180. I'm glad I actually read that angle restriction again, because I completely forgot that it existed. So we have CSC of x is equal to 2, where 90 degrees is less than x is less than 180. So we are restricted to quadrant 2. That's a weird parentheses, but if cosine of x is 2, that implies that sine of x is 1/2. And if sine of x is 1/2 in quadrant 2, then x is going to be, oh gosh, it's going to be two, no, 5 pi over 6? Because we want the angle that's like 30 degrees above the negative x-axis. And I feel like that's 5 pi over 6. Yeah, because if you divide them into 6, you want that very last 6. Well, let me verify that. Because I tend to get a little bit tripped up translating around the unit circle. Five pi over 6, good. Okay. So knowing this, we want to know what's, want to figure out sine of x over 2, cosine of x over 2, and tangent x over 2? Yeah. So 5 pi over 12 isn't unit circle, right? But so we can't plug it in directly, but we can do some trig identities to work it out. So I'm thinking, how's this gonna work? Actually, if sine of x is 1/2, cosine of x is not 5 pi over 6. I can tell you that much. Root 3 over 2. Because we're going to need this fact. I feel like I'm using the wrong identities, though, in my head. Look back at my identity sheet. Because I'm doing a double angle in my head, and that's what's tripping me up. We want a half angle, though. Wait. No, I always get mixed up with the 2 thetas. Sine of twice an... So... if 5 pi over 6... Wait, we want the sine of x over 2. So we do need a double angle. Okay. Yes. Okay, so sine squared is equal to 1 minus cosine 2 theta over 2. That's what we want. It's going to be a little weird, isn't it? Because we have sine squared. We expect sine to be equal to a positive number here, though. So maybe it's not going to be that weird. So we know cosine of x is root 3 over 2, so let's plug that in. It'll be 2 minus root 3 over 4. Right? So you multiply that by 2 over 2, so you get 2 minus root 3 over 2, and then over 2 again. Oh, who's that? Zach! Thank you so much! Welcome in, everyone. I was working on your stream. I saw you were doing one of VOD's famous inequalities, and talking about the meaning of an integral with like partial derivatives versus full derivatives, which I thought was cool. Hello to you too, Zach. Hope your stream is good. I was able to catch those like bits and pieces of it. Welcome in, everyone. So we're on this little like a trig problem, and I always get tripped up with like double angle versus half angle, but I think I've got the key idea down. So I got 2 minus root 3 over 4 for sine. Oh wait, that's sine squared x. That's I think we can safely take the square root of each side and only worry about the positive part of the square root. I'm gonna hope. Does that simplify though? Like too much. Oh, that's like I've seen videos about this. Like it's like a Stanford like math interview question when you have a radical with a radical there. Define addition, the opposite of subtraction. Easy. Correct converter. Like I think this square to square root situation simplifies. And the idea, if I can remember it, you need to figure out something where 2 minus root 3 is equal to a perfect square. Because that perfect square will let you simplify the entire radical. You need to make some realization with how these are lined up with each other. I'm trying to remember it. Minimum of 2,000 pages. Just copy paste 1 plus 1 equals 2 as many times as required. And challenge someone to disprove you. Okay, if 2 minus root 3 is equal to this, what must be A and what must be B? We definitely are going to have root 3 as one of the elements. Some version of root 3 anyway. So just put a root 3 there. So we're going to get potentially a positive or a negative 3. I guess we want a positive 3. And then we want to do a negative 1 here, because we do need a negative sign somewhere in there. I don't think this exact thing is going to work out, but this would give us positive 1 minus root 3 minus root 3 plus 3. So no, that exact thing isn't going to work. What if we flip the signs? That shouldn't matter because it's squared, will it? Just try it anyway, so I can verify my insanity. No, yeah, that doesn't work. Proof by disprove me, bro. Yeah, Russell and Whitehead. For paper, you have to decipher a proof by piano. It was as bad as the 1 plus 1 equals 2 proof. Oh wow. Piano. Does that person have a chess opening? Like the Joko piano? I think it's spelled different. Never mind. It's probably a different person. Or shit, I feel like we've talked about this before. I don't remember. So what's the issue if I work back this? That's positive 1. Do we need a 1/2 in front of the root 3's? I could get a little weird. I feel like there's gonna be some fraction. Maybe I'll just give this to Wolfram Alpha because this is a little bit tricky to simplify. I don't know why the person would have to simplify this as part of a trig class. It's an instrument too with black. Wait, he invented the piano? I do feel like we've talked about this before now, but I apparently I don't remember it. 2 minus... I was just doing... Okay. 2 minus root 3 is indeed a positive number. How do you get that, Wolfram? Tell me your secrets. So there is a fraction involved here. Pay for premium. And no, even with, there isn't a button to give you a step-by-step thing here, so they just don't even care about you. Pay for super premium. That's a good idea. The person was really expected to supply this on their own? How did they get this? 20 quadrillion shekels? Maybe they don't have this in life. Maybe they're allowed to just keep it in that form. Root 2. I think you could make it a perfect square though, Talos, if it simplifies to something like this. Normally it's a bit cleaner, these types of problems. Like, you get something that looks nicer. But I've seen videos about this, like, radical with a radical before, and you can usually work with them. Oh, it's kind of hard. Like, this person, they're in pre-calc. They should. I mean, I guess it's technically pre-calc level, but it's like really hard pre-calc. Like, I guess you can find a perfect square that's equal to 2 minus root 3, I guess. Like, even though it's not one on its own, you can, like, try and figure one out. This one's a little bit hard, though. Am I even doing the right, like... This is so annoying that it's sine squared is equal to cosine of that. Is it easier if we go for cosine first? No, it's really not. Is there a way around this? Like, is there some complete separate way if we work with one of these over here? I guess these are really just rearrangements of each other, though, so I mean, I don't expect there to be... I thought this one would be a lot simpler, I'm going to be honest. Maybe that's why no one replied to this one. Hey, Bonda16. How's it going? Okay, let's just not worry about simplifying this square root of square root thing. Let's just at least get as far as getting to those answers, and we'll type out a reply to this person because it's been 20 hours and no one did get back to them. So at least give them that much. I feel like they shouldn't be expected to simplify though. It's kind of a challenging problem. I'm doing good, Bonda. Just working on this trig problem that it's giving us a bit of a tricky simplification, but maybe just try to ignore it. So cosine squared is going to be the same thing, but we have a plus instead of a minus. Okay. back to the board. Okay, so I'm just going to call this the result of sine of x over 2. So it is technically possible to simplify that, but if this person's able to simplify that, then their teacher hates them. All right, so we also know that cosine squared of x over 2 is equal to the same thing, but with a plus now. Why am I so bad about I sometimes do parentheses and I sometimes don't do parentheses? Should I just do one or the other? We're going to get the same situation here, though, with the radical of a radical. We expect cosine to be negative in quadrant 2, so this time we do want the negative version of the square root, I suppose. And then tangent x over 2 is equal to sine x over 2 over cosine x over 2. So we get 2 minus root 3 over 4 over 2 plus minus 2 plus root 3 over 4. The over 4's cancel. Stick a negative sign out front. Wait. There we go. So I was looking at the wrong line of my own work. I guess if you want to do it for fun, you could write them as one big square root. I don't know if that gets you any simplifications from here, though. Unless you want to do the same like thing we are just trying to do before. So I guess that's the answer. Tangent, we do expect it to be negative in quadrant 2, so that makes sense. We get a negative sign out front. Okay. So as we're on cosines at the very top. Integration, Banda? What about integration? That's a huge topic, Banda. You need to give me a specific question or at least type of integral. Wrong cosine sign at the very top. Oh. Yeah, I didn't end up using that fact. Wait, did I? Oh, I did end up using. Okay, never mind. You're right. Underscore. Cosine should be negative there. And that actually changes everything, doesn't it? Okay, well. Because we have minus and x. So, I mean, it doesn't change everything. Well, it does change everything, but it's really easy change. Becomes plus, becomes minus, plus, minus. Why do you have a hair? Get out of here, hair. All right, good catch on underscore. I think I updated everything. Oh, wait. Not everything. Oh, who's that? The Titanium Apple 2. Thanks for the follow. All right, so I think we're good enough to go on this one. Integration rules? Like, what kind of rule, Bunda? I'm sorry that I'm being so difficult, but like, there's a ton of different topics in integration. I don't have a way of knowing which one you're like talking about. Like, you're talking about like a U sub, integration by parts. just a basic integral, or like I there's different ways that I can interpret that. I don't know which one you're asking about. Yeah, sure, Jed. Integration of regular functions. Like, are you talking about like the integral like sine of x? Or like, just a typical function without anything that fancy? Because that's kind of stuff that you gotta memorize for the most part. I think the answer they had to tell us was their like what they got that presumably was incorrect, or maybe they haven't like checked it yet. Me. There. It seems to me, Wild Woolly Llama, thanks for the follow. I think this is what they got, but they haven't actually submitted it yet to check. And Bunda, I'll look at that more in a second, I guess. Like, it's kind of, I still think I'm not interpreting you correctly with what you want to see, but once people are okay with what's written, hopefully I'll talk about integration a little bit, I guess. So yeah, I never don't know how they get that. Does that simplify? Kinda, but not really. Hmm. This probably can literally do the problem for you like this? This person was right? Okay, well, what did I do then? Product to sum? Oh, that could get you a cleaner answer. Or might kind of avoid this situation. Actually, I don't know. Okay, well, since Banda in chat is asking a question, let me quickly see if I can figure out what Banda's asking about. And then we'll come back to this trig one. So Banda, I'm kind of having a hard time with what exactly you're asking about. Like, so my interpretation of what you're asking about is you just want to know how to integrate normal functions that don't require like a u sub or anything like that, and that's more or less just memorization. It's like you just have to know the power rule that, if you have x to a power, you increase the power by 1 and you divide by that new power. If you have a constant, you just stick an x right next to it. Sine of x, you just have to memorize that it's minus cosine x. You can always derive it back if you want to check. Like if you derive minus cosine x plus c, you do get sine x. Things like e to the x just integrate to e to the x. So it's only something that I can really explain. Besides, you can check things by deriving it back, but This is stuff you just kind of have to know if you're doing integrals. In person whose name is in Cyrillic that I can't read. Hello, I want to learn integrals by myself. What things do I need to know before I start? You know, linear algebra and inequalities, 9th grade math. Oh, okay, so when you mean like, when you say linear algebra means something else if you get to like university. If you have like, if you're talking about like linear algebra like in 9th grade context, I assume you mean like the equations of lines and things like that. And glad to hear that, Bode. Yeah, Jed, I'm gonna have to rework the problem that I just did. Hey, tired student. I'm doing good. How about you? So I'd say that you're pretty close to, I mean, you technically could do certain integrals now if you wanted to. Like the basic ones, like if you have, like you could memorize the procedure of how to do an integral, but if you want to really understand it and do like some more cool things, like I say, like you can do an integral that's like this because it's a pretty procedural thing. Like, you know, if you have x to the 4th, you just do x to the 5th and divide by 5, and that's really all there is to it with a simple just like x to a power. But if you really want to understand what's happening with an integral, you do have a lot of preliminary things that you should be aware of, and I would recommend you to this site that I'm looking at right now. I started looking at the algebra section here. And you're going to want to know polynomials, which a line is a basic polynomial, but there's parabolas, cubics, quartics. All that stuff. So, and there's also trig is going to, or I shouldn't abbreviate. Trigonometry is going to be a big part of it too. Systems of equations, exponential. So there's a couple of functions that you really should be acquainted with. You technically could learn the theory of integrals right now if you really wanted to just push past everything, but you're not really gonna see a lot of cool stuff until you learn the preliminaries, I would say. But all an integral is the area under a curve, and you can get approximations for that just using like rectangles. And the idea of an integral is you make those rectangles arbitrarily like smaller and smaller and smaller, or I should say thinner and thinner and thinner, and then they become a perfect match for the area under a curve. And that's basically the entire idea of what an integral is. And Taos is right. If you are familiar with derivatives, which if you're only in 9th grade math, then you might not be, it is the opposite of a derivative. Tired student, you're saying that you're good. Last test was about polar functions. You got a 96. Nice. Now we're in easy free units, so it's going to be a breeze. Well, awesome. Thanks so much for letting me know, tired student. Glad that your polar functions test went well. Polar coordinates, I think, are super fun. Okay, so what thing did I do wrong with this? Or I mean, I didn't necessarily even. I could have done it wrong. What's it roll from to say my thing simplified to? It got this, but I had an extra. The actual answer was over 4. Is there any way that my thing happens to match that thing? Not really. So I definitely did something wrong. Banda, how can I calculate the areas of curves? By integrating. So, but I think you might benefit from the site too, because I feel like maybe I'm not understanding you because you're maybe new to. If I can guess, you might be new to integrating and might not know how to phrase the question in a way that someone like me who's done integrals a million times will understand, I guess. That I'm not trying to say that in an arrogant way. I hope it's not coming off like that, but if you just want to get the area under a curve, you want an example, I would look at this site because it has great examples. We can look through one together though. Okay. Let's graph this. Hey, is on 1792. I'm doing a few things at once right now, I guess, but the thing I'm doing immediately is Fonda16 over on YouTube is asking about integrals, as well as another person asking about integrals. So right now I'm just describing how to get the area under a curve using an integral, I guess. So Fonda, so the example that they give on the site that we'll look through is you're integrating x squared plus 1 between 0 and 2. And these 0 and 2 are x values, so I'm going to draw on some vertical lines here. Wait. Okay, cool. So if you have this parabola here in red, and you want the area under it between x equals 0 and x equals 2, you can do that with an integral. If you want to do exactly. You could get an approximation if you want to use like geometry and draw some rectangles in here. But if you want to do it exactly, then you need an integral. And so that's what this integral actually means. And you actually evaluate the integral by they're doing it a complicated way. Oh, dang it. Okay, they weren't doing it the way that I hoped. They're doing it a different way. Calculus classes make you learn that way once, and then they never talk about it again. I'm just gonna do it on the board. Tired student, if it's just a for fun problem, if there's time, I'll look at it. If people are gonna keep asking homework questions, then I'm gonna prioritize those. Sweetheart, I'll get to that after I do this basic integral version, because that'll be like the next step up. And then banana, can you help with this following problem? X to the fourth plus 2y to the fourth plus 4z plus 8t to the fourth equals 16 xyz t. They're integers? What kind of crazy Fermat stuff is that? I'll copy that over to the Twitch chat in case someone has seen this type of problem before and knows how to get an integer solution to that. I don't know off the top of my head how you would approach a problem like that. Your endpoint is Lagrangian mechanics, so you need to understand integrals very well for differential equations in the first place. Do you have any tips? None beyond just it. If you want that basic calculus understanding, I'd absolutely use the site that I linked. But I don't know Lagrangian mechanics, so I have a hard time saying anything more than that. Okay, so, oh god, I don't want to lose my work. It's fine, who cares? God dang it. Okay, you're getting sprayed, whiteboard. Okay. So, if we're talking about the integral from 0 to 2 of x squared plus 1 dx, which is the problem that I showed on Desmos before. Yeah, Vlad, we agree. So When you, I've given like kind of like the geometric interpretation of this, or I mean, I kind of did, but where it's the actual area under the parabola between 0 to 2. If you want to actually compute that, we start with the inside here, and we apply the power rule. So here we have an x squared, so we increase the exponent by 1, so we get cubed, and we divide by that new exponent. So you can either do over 3 like that, or you can multiply by 1/3, it's all the same. Just one, sorry, when you have addition, you can, if you're actually only just now learning integrals, if you have addition in integral, you can split up into 2 separate ones and worry about them separately. And that's what I did mentally, but I've done these so many times that I don't usually write out that step. So what I integrated x squared and I got there, and then when you integrate 1 integrates to just x. You can always check that by deriving x back, and you just get 1. And now we say that this expression is evaluated from 0 to 2. And now you plug the 2 in for the x's, and then you plug the 0 in for the x's, and you subtract them. So when we plug in 2, oh wow, no one claimed first. When we plug in 2, we get this, 2 cubed over 3 plus 2. And then if you plug in 0, or there's a minus sign there, you get 0 cubed over 3 plus 0. So 2 cubed over 3 is 2 cubed is 8, so you get 8 over 3 plus 2. 0 plus 0, you subtract 0, it's all 0. This entire thing on the right is 0. So you get 8 over 3 plus 2. If you want to be fancy, we can get a common denominator. It's what? Why can't I do math? 6 over 3? 14 over 3? So 14 over 3 is the exact area under that parabola from 0 to 2. So Sridhar is asking kind of the evolution of this question, which is if you want to be between 2 parabolas, let me actually catch up with Twitch chat. Bode might have a potential solution for banana. Wow, they're all equal to 0 unless you maybe made a mistake. Okay, I'd love to be able to read chat while I'm at the board. That takes, like, I have to buy some kind of separate screen and have it mounted on the wall next to the thing, though, and that's like, that's a lot. Okay, so Banana, if you are still here, Bode is saying I'll copy paste it over to YouTube chat. I don't know really how to do these for myself, but at least you have one person saying that the only solution is everything equals 0. Oh, I thought it was 16 times XYZT. Maybe it's saying XYZT, it's like 16 comma XYZT are, oh, it is 16 times XYZT. Okay, in that case, all zeros is definitely a solution, even though it's trivial, I guess. Banana is asking, how did he get the inequality? I think Bode just invented that as a useful tool for analyzing it. Bode is saying arithmetic mean, geometric mean, or AMGM. Or, I think Bode turned them into inequalities so they're easier to analyze using arithmetic mean and geometric mean. You might be expected to do this some other crazy way. I'm not sure, to be honest, but I know that Bode uses that technique for a lot of problems. You'll look at it? Okay. Yeah, I mean, no, regardless, it's kind of a really hard problem to solve. And Talos was saying earlier, not to derail the conversation, it turns out the root of 8 plus 8 root 3 is root 2 plus root 6. Now I wish I didn't erase my work. I had... No, oh, I still have the Wolfram Alpha open. Yeah, I guess I forgot a constant, or I don't know, I did something wrong there that if people stop asking questions in chat, I'll get back to. Hey, Yanis. Okay. Brad is saying for Lagrangian mechanics, you need to do differentiation, then integration, and ordinary differential equations and partial differentials. Okay, yeah. So Bond, if you have any questions on that kind of basic integral, let me know. Sweetheart, can you show the example in which we gotta do the area between two parabolas? How do we know which curve is higher? That's a good question. If you're talking about two parabolas specifically, it's where you have to have a good intuition for how functions behave. It's something that is a pretty challenging part of calculus because many students tend to just glide through the classes before calculus, and it really backfires when you take an actual calculus class. If we're talking about parabolas specifically, I'll invent two parabolas and we can figure out together which one is greater than the other. I guess we do have to name an interval. Actually, we don't necessarily have to. We can just see generally where they're greater than or less than each other. It's probably a better exercise to do anyway. Okay, so let's pretend that we have one parabola that is x minus 1 times x minus 2, and if it's not factored already, having it factored can be really helpful. And let's say that g of x, it's a good example. You know what? We change that to be 3. Say g of x is x plus 1 times x minus 2, maybe? Even stick a negative sign in front. Did some algebra today, and a really nice theorem was pretty close to some elementary number theory stuff you've been doing. Oh, cool. If you want to drop it in chat, if there's a moment, I'll take a look at it. Or in Discord. All right, so these are just kind of two problems that I know more or less off the top of my head. I think they'll be kind of interesting to figure out which one is greater than or less than, I hope. So the thing we have to remember about parabolas, or we have to think about how parabolas actually behave, unless you wanted to compute a whole bunch of example values, and that's kind of a drag. So parabolas, if we have them in this form, I wrote them in this form because it's very convenient to get their roots. So that gives you two like hard points for each that are really easy to find. This one has 1, 0, 3, 0. This one has negative 1, 0, and 2, 0. So let's do some color coding, I guess. Say g of x is green, f of x is red. We'll have some Christmas colors. What was that noise? Oh, I think that alert bugged out. Finger UA, thanks for the follow. Wild Woolly Llama. Mersenne primes in the Collatz conjecture? Maybe I'll look at that more in a minute. I'm not very familiar with either of those. Let me get through this problem and I'll think about it a bit more. All right, so g of x, like I said, we get the two easy points of the zeros for free, so let's draw those in. Same with f of x. So now the other part of parabolas is you can figure out if they're facing up or down super easily by their leading coefficient, if it's positive or negative. So f of x, it has the positive leading coefficient, like there's no minus sign in front. That means it opens up, like a smiley face. And g of x has a negative sign in front, so it opens down, well, like a frowny face. So I'm not even going to bother drawing any other points in. I'm just going to kind of vaguely draw a facing down parabola that goes through those 2 points that I drew. And then I'm going to vaguely draw a parabola facing up that goes through the other 2 points that I drew. And the important thing here is that you have to remember this is not exact, but it gives you an idea of how many and where your intersection points are between these two. And the intersection points are what you want to worry about, because that's when functions change from being greater than or less than each other. So if we're working, if we pretend we're working on an interval that's like, you know, completely in the negatives, it doesn't really make sense for the area between the two curves, does it? But I mean, this is more or less all you need to know to kind of figure out the areas between curves. And if you're really unsure if you did your drawing right, plug in a value between the intersection points. And you don't have to do the math that exactly, but if you just get a sense of which one is greater than the other, just by being like, oh, you know, you get a pretty high number up there and a pretty low number down there, or, you know, even one is positive and one is negative, then that's how you can tell, like, you know, between these 2 points, which is greater. But, you know, when you get some like crazier functions, that's harder to predict where and how many times they intersect. This kind of general drawing can really help you like visualize it. I see Yanis is putting the algebra problem in there. Bode is talking about Llama's problem. Thank you, Bode, for looking at it. So Sridhar, if you are still here, let me know if you have any questions, but that's kind of the... If I'm given the area between 2 curves, and I'm not given the graph, I'm usually drawing something like that on paper, or I'm mentally doing it in my head. And the more you do this, the more intuition you get for how functions actually behave, and the easier it becomes. But yeah, and if you're really uncomfortable with it, you might want to even like take some more time with it and like plug in some more example points and get better drawings. But if you're comfortable with how like the functions behave, you know they're not doing anything crazy, then you can just kind of get a vague drawing too. Okay. So I don't think there are any other questions from YouTube chat unless Tired Student does want to put that question in about polar coordinates. So I'm just like scrolling up in Twitch chat to see if I missed anything. If someone did write something that I missed, then that's my bad. But yeah. So okay, let me read a bit more thoroughly what Wild Woolly Llama is saying regarding Mersenne primes and Collat's conjecture. Is there any known connection between the two? So if you do 2 to the n minus 1 for 3, the next number, which is 4, and do Collat's conjecture, 4 over 2 equals 2, 2 over 2 equals 1. Yeah, I definitely don't know anything about off the top of my head. That seems like something where someone would have noticed it though, right? What games do you play, Tired Student? I'd say the one that's probably been the one game that I've been playing ever since I started streaming, I haven't stopped, is called DayZ, multiplayer zombie survival game. And then other than that, it's kind of been a variety. Like the other like kind of mainstay games have been Factorio and Satisfactory that I've done like very long term. But like I'm gonna be doing some played up hopefully tomorrow with Talos and potentially more people. I trying to think of other games that I played. I know I do a variety of games. I stream it over on Twitch. I don't really do it on YouTube, at least right now. Play Minecraft with everybody in the math community. I don't really want to play Minecraft though. I think I've heard Penn Center talking about playing Minecraft. I don't know if anyone else in the math community is interested in it. Oh, yeah, Yanis, you put that algebra problem. Oh, hey, okay, here's a Stack Exchange thread. You play competitively Fortnite, Rocket League, and Valorant, Minecraft on the side with friends. When you say competitively, like, are you an actual pro, or do you mean like you're doing like ranked? All right, so yeah, Wild Woolly Llama, I'll link you to this. I don't have anything that I can really contribute for myself, folks. I'm just not familiar enough with this stuff. But it sounds like you're not the only one to have noticed this. High rank top 10. Wow. What a gamer. See, maybe that's why you're so tired. You're always just gaming. Fortnite, Rocket League, and Valorant. I'm gonna be honest. Rocket League and Valorant, I kind of hate them both. Fortnite, I played it when it first came out and I liked it, but I'm not too into it anymore. I'm glad that you enjoy them though. They're good games for people who enjoy them. I just don't enjoy them. Oh yeah, no, like it seems like a neat thing to notice. Geometry Dash. I think I've heard of it. I don't know if I've ever watched it. Rocket League is amazing. I don't know. I just, it just kind of makes me rage. Like, why is it so hard to control? All right, what the heck is up with this? I only play cool games. Yep, that's the problem. All the other games are lame. Yeah, well, I'm glad that someone who's more knowledgeable about it was able to like to discuss it a bit, because I feel bad when people come in chat and I don't even know how to engage with it, but I think that there's often people around in chat who do want to engage with it. So saying skill issue, I guess I am, Yanis. It's just it. What? Why can't I just play a racing game and then play soccer? And yes, it's soccer, not football, but not like both at the same time. You know, it's like intentionally difficult to work with. It's football. Let's just settle it. Football is taken. It makes far more sense to say that football is the game that barely involves using your feet. Um, can't argue with that. I mean, it does start with the kickoff, to be fair, but yeah. And there's punting. So Talos was suggesting that there might have been a product to sum identity going on in this trig one that we were talking about before. Which, it's probably possible. I'm just trying to figure out how you would use that. Like, if they're both sine of x over 2... Oh, that just boils down to the half angle. Never mind. I guess I started talking about soccer in general, tired student. In the classic argument of, you know, American football versus rest of the world football. did this person get that? So it looks like root 2 over 2 plus like root 3 over 2, but the square root is over both of them? Wait, root 6... Okay, let me make sure. Did someone answer this first? No. Okay. Let me just Google this, because I want to know how to do this, and it's annoying me that I can't figure out how. It's a similar problem. Did I? Wait. What? Oh, okay, so they did this simplification thing. So this is the same formula that I used. Why did I not get the right answer? Like, this is what I got, and it doesn't boil down to this, it seems. Or does it? 9, 5. Oh yeah, those are very different numbers. If you look at the decimals. Okay. All right, we're going back to the drawing board on this one because this is something that I should know how to do. By drawing board, I mean whiteboard. Oh shoot, Yanis put the algebra problem in. I'm just gonna work on this one and then I'll go to that problem. Yanis, sorry that I forgot about it. This trig one is kind of bothering me though. Cosine of x is minus root 3 over 2. Okay. So, sine of x over 2 squared is equal to 1 minus cosine x over 2. Let's verify I set that up right. Looks good. Cosine of x, we said is root 3 over 2. Minus root 3 over 2. So you get 2 plus root 3 over 4. So you square root it and take the positive one to get Well, so I just got the same thing that I already had a second ago. I've already made a mistake, it seems, but I don't get where. Actually, wait, I was plugging it in wrong. This might... Wait a minute. It's 2 plus root 3 over 4. I didn't update Wolfram. That's still 0.48. And that was 0.96. So I still did something wrong. God, this is so annoying. Because the website I looked at with a similar problem just did the exact same thing that I'm doing. Let's go to a different one. Should wait. Let's get this one. It's the exact same problem. Wait. Oh, they're taking it as 2x. I think they mean x over 2. But 2x is pretty reasonable interpretation. This person messed up the sign, though. That should be minus root 3 over 2. Yeah, I don't believe this. Oh. I don't like the calculator method. Oh, wait, you know what? What is sine of 5 pi over 6? We can verify that much. Like, did I mess up that fraction horribly? 0.5. That's what I expected, right? Right. And then over 12 is the 0.96. God dang it. So this answer is right. What are your strongest and weakest subjects? Sorry, student asks. That's a good question. I feel strongest with, like, I guess, like, the first semester of calculus stuff. Like derivatives and the basics of integrals, and I guess also the second semester of calculus. Weakest, and I guess the weakest of things that I have studied, because obviously if I haven't studied it, I definitely don't know it. Probably like geometry. My stats is a little bit rusty as well. Besides math, my strongest. Ooh. um. I kind of That's a tough one for me to answer because I'm the type of student that, like, I'll just grind however much time I need to get good grades in all my classes. So I didn't get a particularly bad grade in any class. So I'm trying to think about like weakest in other terms, like what I'd put the most effort into. I had to put a lot of effort into like chemistry because it was so much memorization. And then physics wasn't the easiest thing. Electromagnetism at least wasn't. Yeah. But I think chemistry sticks out as the thing that was like the most annoying for me. Well, yeah. And annoying relative to how much enjoyment I got out of it. So there were things that were more annoying, but they're at least more helpful for me, I felt like. Oh my, I hate these answers on this website. I think apparently no one can do these right, including me. Hey, Hardlucked. Phobos, what's the current question? Okay. I'm working on this. According to Wolfram Alpha, the person got the right answer for that sine of x over 2. I can't get it for the life of me, though. How's it going, Hardlucked? Chemistry's a little boring for me. The only thing that got you going was thermodynamics. We never even got into thermodynamics. We were just like balancing equations, doing the periodic table. Was like molar amounts or whatever, like, you know, converting grams to moles and then going to the other side of the equation. What else did we do? Acids and bases. I don't know. It was all kind of stupid. Wait, what about a chinchilla to buy your daughter? Am I misinterpreting that? Is there some kind of like chinchilla-based bet that's happening? Because if so, I think that's awesome. If it's a thing, oh, I love that. So yeah, where I've gotten on this one, the answer that I got using double angles is on the board. I got the square root of 2 plus the square root of 3 over 2. And that numerator does simplify, but it's not equal to the correct answer, regardless. So I've clearly done something wrong here, and I can't really figure out what it is. And like all the problems I've been seeing online, like they do it wrong or they do it numerically, and that seems kind of stupid to me to do it numerically. Because this is a math class, you know, it's not physics. Get rid of this ping on my Discord. Stream elements, you're pinging way too much. Okay. Anyway. It's my birthday on Pi. No, it's not. What my birthday is top secret information though. You need 1 + 2 + 4 + 8. Doesn't 2 to the n, isn't that what a Mersenne prime is? If it's 2 to the n minus 1 or something like that? Okay, you know what? I'm apparently just stumped on this trig question for now. Let me at least look at Yanis' question because it's been a minute. Copy pasting what Yanis said before. Okay. I'll put it over into the YouTube chat too. Okay. K be a field, which I have a 1% idea of what a field is, but I assume if Yanis gave me the question, that's not the most important part of this. Let kx be the polynomial algebra and p in kx. Still don't know what this means. Then kx over p is a field if and only if p is maximal. I assume this does reduce to some type of number theory problem. I don't know the vocabulary here, though, to figure out how to interpret that. Send this mainly because of proof similar in spirit. Okay. Well, I mean, if you can like give me a little push or something, I can try it, but I don't think I have the foundational knowledge to understand what's happening with that question. Okay, let me 2 plus square root of 3 over 4. The thing before I took the square root, what is this equal to? 933. 1 plus 1 equals 2, Storm. I don't know about that. And what happens if you square this thing? Hey, Storm. 933. Really? Something went wrong when I square rooted this? Is that what you're telling me? Wolfram? Huh. What is Wolf? Okay, if I take the square root of this entire thing, what does Wolfram say that is? I feel like I did something terribly wrong here. 2 plus root 3 over 2. What? Now Wolfram says this is... What did I do? What? It was saying that was like 0.1 something before. Oh my god. Apparently I did it right. Wolfram was just being moody and telling me weird things. I don't know, Brownie. Wolfram was making me doubt everything that I know. It's playing mind games. All right, how do we simplify the square root of 2 plus the square root of 3? It's gonna... Well, I guess we can kind of cheat. If there's an over 2 over here, then that means it's going to be root 2 over 2 plus root 6 over 2. Like, let's reverse engineer that. So hi, Brownie. I hope you're good. What a freaking journey this problem's been. I just put it there in the corner. The answer that the student had there is correct, according to Wolfram Alpha. I got to here, and when I plugged that into Wolfram Alpha, it was giving me a different decimal than what the student entered in that text box. But apparently, when I entered it just now, they were the same, so I must have entered it wrong, or Wolfram Alpha was interpreting it wrong, or something that I don't know. I think I just shouldn't question it, though. But the task at hand, I guess, is to simplify the numerator there. So you can name a perfect square that's equal to that thing inside the square roots, and that's what we want to do. This one's a little bit tricky to do it with, though. But with the power of Wolfram Alpha, we actually already know the answer. Apparently, it is root 2 over 2 plus... They said root 6 over 2, but I want to work with that a little bit more. Like, can I rewrite that in a form that makes it a bit more clear what the hell is happening? So if you multiply this back out, let's verify that much. Root 2 over 2 squared is 1/2. Oh my god, what's happening when you multiply them with each other? Is that just root 12, which is 2 root 3? Then that one squared is 6 over 4? What is this? Two plus 2 root 3? It doesn't make sense. It should be just root 3. It's root 12 over 2 times 2. Let's multiply it out a little bit slower, I guess. Over 4. There we go. That's what I did wrong. And then that becomes 2 root 3 plus 2 root 3 is 4 root 3 over 4 is just root 3. Okay. That makes sense then. Okay, so we can say that 2 plus root 3 is equal to, in parentheses, root 2 over 2 plus root 6 over 2 squared. And that squared is desirable because of the square root that's on the outside. So we can say this is equal to root 2 over 2 plus root 6 over 2 all over 2, which is root 2 plus root 6 over 4. Okay. God, that's annoying. Hey, thank you, Brownie. So how can we work out cosine x over 2 now? You could go back to your double angles and do the same process that we just did. And I think that's kind of that's probably what you have to do, unfortunately. Because you could do like Pythagorean theorem or something too, but I think you're going to get the exact same issue. So just use the same process that we have been using, but with cosine squared. So we'll get 1 plus cosine x now over 2. Cosine x is negative root 3 over 2. Get a common denominator. 2 minus root 3 over 4. Now we'll take the square root, but this time we want it to be negative. Because we're expecting a negative answer for cosine in quadrant 2. Now you have to add, you have another thing to simplify here that's an entirely separate problem than that one because you have a minus sign. Can we just blindly insert a minus sign in there and hope that it works though? Like it should be nearly the same, right? If it is the same thing with a minus sign, you get 1/2 minus that, plus that. Aha, it is just the same thing. Okay. So we actually get to save ourselves a bunch of work here. It's really going to be that with a plus, right? No. Eee. Sorry, it's going to be that with a minus. And you can even make that √6 minus √2 if you want to clean up the minus signs a little bit. Fair enough. And if you want tangent, now you just do sine over cosine. The over 4s are going to cancel, so let's just not even bother writing that because I'm getting lazy. Over √6 minus √2. Let's rationalize the denominator. You'll get 6 plus 2√12, which is 4√3, plus 2, over 6 minus 2. So you get 8 plus 4√3 over 4, which is 2 plus √3. Aha! Wow, that's kind of elegant. Is that? Let's check that against what Wolfram did. Terry student, nah, this is trig. There's no calculus happening in there. But thankfully, we got to the end of this cursed problem. I think. Let's make sure that Wolfram agrees. Back. Oh, Wolfram. Okay, it agrees with the answer for tangent. Wolfram gives that in a different form, though. Aha, it does agree. Okay, good. Oh, it took it away? Okay, 0.258. Square root 6 minus square root 2 over 4. Hey, 258. Hell yeah. Same decimal. Okay, we're right. Oh. No one else answered this one, so let's do it. So it's kind of weird to me that if they're able to get sine of x over 2, I wonder what their holdup was for cosine and tangent. Oops, 1 plus. All right. Oh, not sin x. Sin x over 2 and cosine x over 2. God, that one was a journey. Cannot understand how to solve this. Oh God, one of these. Okay. The larger of two numbers. Oh yeah, critical thinking. What's up? Same as the shape of the trapezoid shown in figure 2. The height is 20 meters, the width is 50. At the top. Wait. The width is 50 meters at the top and 30 meters at the bottom. Okay. Find the force on the dam due to hydrostatic pressure if the water level is 4 meters from the top of the dam. Okay, this one is nicer because it is a bit more specific about where the trapezoid is. Okay, thank you. Okay, good. That picture does help a lot. Okay, so... And this time your problem is in meters. Okay, good. So we get to use nice metric units. The x came from for 1,000 GXI. That's going to be the depth of the, like, strip of plate, I guess. Wait, why isn't this working? No! Set. Why doesn't set problem do it? Come on, streamer bot. What? Why? Streamer bot. Oh my god, I think this thing happened, the same issue happened to me before, where it doesn't save my command. Oh, I didn't hit save. That's so weird. It saved the other parts of this, though. The commands... Okay, give me one second. I need to figure out why StreamerBot is so freaking stupid when it comes to this command thing. It's happened to me before, where I make a command, but it just deletes itself. Set problem. Show problem. Show problem. Okay. Group. Just one more second. Okay, now it'll work? Come on. You know, I probably need to redo the triggers now. Okay, that's hide problem. Okay. That's set problem. Okay. That's show problem. Save. Okay, now it'll work. Sorry to the... There we go. It's not even like that big of a deal, but it's just annoying. It doesn't work. Okay. All right, let's clean off the board. Freaking streamer bots sometimes. Okay. So, got water. We have a trapezoid. It's a big trapezoid. Height is 20. I'll look at that more later, Yanis. 20, 30. This is definitely not to scale, because that's 4 right there. Do you want to know where the x came from in 1000 xgi? Okay, so... I have an interesting problem. I mean, so you'd say 1000 xgi? Or 1000 gxi? The way that I'm thinking to set it up, I don't think we would get that. Like, you don't have the line y equals x. Yeah, I know that 1000 is the density. Yeah. So... Okay, let me... I feel like it's not going to be x either. It's going to... The reason why something is there at all is the equation for pressure is density, gravity times depth. And I feel like depth isn't going to be as simple as x sub I. Yeah, so we like, but the area, it's going to be more, I mean, I guess it's only the depth. Okay, that's fair. We worry about the area in the second part. Okay. Right. Okay, I guess so. What did I say the area is in this triangle case? So I'm kind of thinking we want to split it in half vertically and multiply it by 2 to make it easier. The area doesn't change with how you arrange the bases as long as the bases don't change. Isosceles versus non-isosceles trapezoid. Wait, what the heck is an isosceles trapezoid? Is there a trick for getting the area in the case where it is currently rather than doing the splitting in half thing? If I'm missing a trick, Talos, please tell me. I'm thinking... I think it'd probably be simpler if we split it in half vertically. I should see what the answer given is. And I should mirror that setup if we can figure it out. (46 minus x sub I). Okay, that's helpful. God, these problems are always so confusing with how we set up the coordinate system. Because here x is vertical, which makes me uncomfortable. I want to see if they're dividing it in half or not, I guess. Cause that's what my instincts are saying to do, but I don't want to do it in a way that you're not supposed, or that I want to help you understand the way the book is doing it, I guess, rather than the way that I would do it. It's probably more relevant to you, I guess. Why is the depth of the water 16? Shouldn't the bottom of the trapezoid be 24, not 16? Because if the... Did I draw the picture wrong from the get-go? Oh, if you set... Nope. They're taking the origin as the top of the trapezoid? But no, you should still get 24. Like, the bottom of the trapezoid is 24 deep, isn't it? Yeah, I'm understanding the picture less and less now. The depth of the water is 16. should do 20 plus 4, surely, not 20 minus 4. Oh wait, it's a dam. It's 4 meters below the top of the dam. Oh. God damn it. You have... Oh, God damn it. Get it. I didn't even mean that. Okay. It's a dam. I was thinking it was gonna be like that drum problem that you posted before, where the entire thing is submerged in water. But no, it's a dam. If your entire dam is submerged in water, then you have a pretty crappy dam. Didn't build it high enough. Okay, so there's just part of the trapezoid that's completely useless to the problem at hand, and that's okay. We just need to deal with it. Okay, so now I'm on board with the water being 16 feet deep. Just reading through the rest of the problem now. Approximately a rectangle with height x and width w. Yeah, so I was thinking divide it in half to make this next part a little bit simpler, because if you have to go from this triangle all the way up to this triangle, it just seems a little bit less convenient than going out from like this triangle to the straight line. But I guess let's see how they deal with it, and I can try to explain this a bit better once I understand that bit. So it sounds like you're just asking about the setup critical. So the height is delta x, the width is w, and we need to figure out w in terms of x. What is a? Like, I've figure 3b. Okay, a is the top of the triangle. A over 16 minus x I is equal to 10 over 20. Okay, so I get that part about the similar triangle where you make like that vertical slash there. They flip each. They solve it for A. Okay, never mind. So the width is 2 times 15 plus A. Oh yeah, so they take the half, so this 15 plus the A multiplied by 2. Okay, so they do kind of cut it in half, but yeah, in the way they do it, you don't really have to worry about it that much. Okay, and so this isn't the part that you were asking about, though. You were asking about this particular x sub I, right? Those have the same area, Talos? Oh, I guess if the height is the same and the top and bottom are the same, I guess that makes sense. Okay, so yeah, I guess you could use that to simplify the calculations a bit. Yeah, okay, so critical thinking. In regards to yours, there's a question about this one. For getting the pressure, the x sub I is just, it's always there and it's always just the depth. And in this case, they specifically defined x sub I as the depth. It depends on where you set your origin. So I think in theory, it could look different in different problems. But they intentionally set the origin so that it's at the top of the water level. So it's just a simple x sub I. And like where like x goes down into the water. Why do you even need x sub I from density and gravity? That's just the equation for pressure in this situation. The pressure on a very like, you know, small piece of the plate is just the density of water times the acceleration due to gravity times how deep it is in the water, because the deeper you are in water, the higher the water pressure is. PGD is not included at x sub I. In this setup of the problem, depth and x sub I are the exact same thing, because they place the origin conveniently for that to happen. It doesn't have to be x sub I exactly, but if we're taking this picture as our setup, then it is. So I think like the one we were looking at, or the one I was looking at to do like example 2 here in Paul's, I think the depth was slightly different. All right, so when it's like fully submerged like this, it's going to potentially look different. Like, so like in this one, it was 9.81 times 1,000 at times 8 minus, you know, they say y sub I, but that could be your x sub I also. So it's not necessarily always x sub I, but because they put the origin where it is, in this case, it is just x sub I. Okay, student, this is calculus 2 question dealing with hydrostatic pressure on a submerged plate. Basically, in the case, it's a dam. Their problem statement is up at the top there. Where hopefully it's possible to be read on the stream. Hey, hoo-hoo. How's it going? So, does that help you with why the equation for pressure is like that with just the x sub I? Is there anything else that you want to know about this, or are you still confused about that piece of it? That's all you want to know? You think you need to figure out how to do it later? Okay, sounds good. Glad I was able to help you out with that piece after some struggles. Doing great. Glad to hear it. I'm doing good too, Hoo. Nothing too much new with me. No problem, Critical. Thanks for the question. Actually, I don't know if Dallas is listening to stream. Let me right back to them in text. All right, so let's close out of this. Okay, does this one have an answer? It does. Oh, let me, now that I got the commands working again, there we go. Okay, let me quickly erase what's on the board and then we'll look for a new problem. Okay. Get a cough drop too for my throat. You know, this morning it started off rainy, but now it's nice and sunny again. Kind of funny. The weather's been super weird. It's been like 1 week hot, 1 week cold, kind of like switching on and off. Ooh. I really wish they posted the original question. Hmm. Really? For a pooled t-test, I never did anything like that I can remember. Usually they'll just tell you that you can assume the variances are equal. Yeah, I'm not sure I remember this one well enough. Or I don't know if I even learned it in the first place. Anyway, Yanis responded about like the number theory equivalent statement. Oh, okay. Problem will be hard for me. Never mind. I won't look at it that hard then. Okay. What whiskey do I prefer? I like whiskey. I need to try more of it though, because I don't really have a preferred whiskey right now. Like my default was like Jameson, but it's not really that good a whiskey, so. I guess I don't have one like right now. Well, yeah, my family always has some Jameson around, so I'm definitely like used to it. Mm. Not going linearly up. If I had to flee America, what country would I go to? Well, if you're saying I have to flee America, I assume I did some kind of crime. And I think countries that don't extradite is a pretty short list. I don't know if I have a bunch of options there. And it's just about like what. I mean, neither will sound too appealing to me right now, bio. I'm not gonna do this one. They need good mathematicians. They better keep looking if that's the case. Um. Oh God, epsilon delta. Oh gosh, it's not even a discontinuity or anything. I've done this one before, technically. Um. All right, let's see if we can figure out the epsilon delta for this again. I've done it for this form of a um of a function, but it's been a minute. Yeah, sure, bio. Oh gosh, what's happening with this one? Just put 3 in place of x? I don't know what that'll do for us. Find... Ooh, so you're finding the form of the intervals where this is valid? Without having to necessarily find the exact ones? Find all real solutions? Let me, It just says find all real solutions to this? Like where the inequality is valid. Well, you can subtract over the piece not under the square root and square each side. I feel like it's gonna be... Okay, well, let's cheat and look at the answer first, because I'm nervous this is going to be more complicated than I'm making it. And then we'll look through and figure out how to get it. Okay, so we are expecting greater than 0 or less than -1. There isn't a third. Oh, or -1/2. Okay, so we're expecting, I guess, this first case. We have a whole range of solutions from -infinity up to that first thing, a singleton, and then for some number out to positive infinity is what we're expecting. So let's see if we can actually figure that out. The first one is the answer? Okay. Hey, Shuan, if you do have an idea for the problem, feel free to say it more. I'm just not sure what, like, plugging through could give us some intuition for the problem. I guess it just won't necessarily help with figuring out the exact where things start and end. Great. Let's check it. Candidates is going on. Oh, right now I forgot to check the time zone pro moment. Hikaru's in trouble? Oh man, okay, after this, let's go like check in on that. Who is Hikaru playing? What do they mean by A, B, and C? They just mean that we're gonna get 3 numbers for where this inequality is potentially valid, basically. We're gonna get x is less than or equal to A, x can be equal to B, or x can be greater than or equal to C. If we already know what the answer is, it's gonna be like this, where A, B, and C, we have to figure them out. There might be a way you can do this intuitively. I want to start by subtracting this over and squaring each side, but there might be a completely different way that we can do this intuitively. Actually, wait. This is a squared number, so it's always positive, plus a square root, which is supposed to always be positive. So as long as the square root is taken care of, this will always be greater than or equal to 0, because you're doing a positive number plus a positive number. So maybe we only need to worry about where the square root is valid. So we can just boil this problem down to 2x plus 1 to the 4th minus 2x plus 1 squared is greater than or equal to 0. Because everything else, I think, is fine with the inequality. He's playing Caruana. Oh, wow. That's a good matchup. Okay, so if we want to solve this problem, I guess we can factor it to 2x plus 1 squared. So from... I hope this is valid to do with an inequality. I feel like it might not be. But let's just see what this gets us. Well, this number is always positive. So actually, we don't even have to worry about the left side. This is the only one that's potentially negative. So we actually, yeah, this is completely fine for us to break it out like this. We want 2x plus 1 squared to be greater than or equal to 1. And I guess we can square root each side and get 2x plus 1 is greater than or equal to 1, or 2x plus 1 is less than or equal to -1, I think is how this works. And so you get 2x is greater than or equal to That's not good. Is that good? I forget. What's the answer supposed to be? We were getting... I don't think this is good. Oh, wait. Maybe it is good. X is greater than or equal to 0, x is less than or equal to 1/2, and x is equal to -1/2. So from this one, x is greater than or equal to 0. But this one, x is... Oh, I did that wrong. There we go. That makes more sense. -2. Okay, so this is actually most of the answer here. That matches with what Malfa said, that x is greater than or equal to 0, or x is less than or equal to -1. But we still have that third answer to worry about, which... This would be very hard for me to spot on my own. But I think we haven't considered a case... Okay, so... I think the flaw in my argument that I said initially is that we said this is a positive number plus another positive number, so it should always work. But these can all be 0. That's valid too. So we have to be able to consider the case where all three, like, you know, this is 0, that's 0, so you get square root of 0, 0, and that's 0 as well, because they're all 2x plus 1s. So they'll all be 0 at the same time. So that's why we have to know to check the case 2x plus 1 is equal to 0 separately. And from that, you get x is equal to -1/2. So your answer in total is x is less than or equal to -1. So -infinity to -1. My notation for this might be different from your notation. I forget how it looked on the problem. Singleton 1/2. And then x is greater than or equal to 0. Okay. See, I think that's how you're supposed to do that problem there. They're talking about Mersenne primes and the Collette's conjecture, which are two things that I don't know very much about. Yeah, I hope that makes sense, Bio. You neither just have So wait, is chinchilla a different thing, or is that a chinchilla? Like the small fuzzy creature? Okay, when I Google it, it's bringing up chinchilla. Oh, okay, no worries at all. Llama. I mean, you know, what's so bad about a chinchilla? Take a look at the next one. Let's see. Ooh, we got nested absolute values. Oh, if you have 2 cats. Okay, that's a pretty fair thing. Yanis, I do still plan to, but I don't want to work ahead of Penn Center, because I realized the last time I read from the book, I was ahead of Penn Center. I got the timing mixed up, and since the Penn Center's reading group, I don't want to work ahead of him on stream, because I feel like that's kind of stealing thunder. So I might go back and do some of the number theory stuff. So the last time I caught Penn Center stream, at least, he was finishing up the number theory stuff and the equivalence relations and the functions. And now they're currently on group theory, but I want to wait until Penn Center's already streamed the group theory stuff before I stream the group theory stuff. So I could go back and do some more of the number theory problems, but I don't want to go into the new stuff at least until Penn Center's done it. The largest number of real solutions that where p is a real parameter. I don't know. Oh gosh. I just want to respond. I don't know to all of these. The largest number of solutions for this where p is a real parameter. How do we, like, I could put this into Desmos, but I want to see if I can figure out some kind of intuition first here. How hard a question you ask from 1 to 10? I would say an 8, where some of them are stupidly hard. Some of them are okay. A lot of times I think there's just tricks that I'm just not aware of, which is why I'm not going higher. Could you somehow break this up into, like, I guess 4 different cases? Or maybe you don't even need to worry about it that much. Maybe, I am going to put this into a grapher at some point. I think it's more interesting to try to figure out without the graph, though, first. Okay. I have somewhat of an idea of how we can try and graph this. So let's try to wrap our heads around it. So I'm going to completely ignore the p for now. That'll come at the very end, I think. We're going to try and graph this and see what basically horizontal line we can draw through it that'll intersect the graph the most times. And I think that's the solution technique that makes sense to me. I'm doing this blind. Because having the equal to p is basically drawing a horizontal line like that, so. Okay. So we have the absolute value. Oh my god, I'm already off to the wrong start. 2 minus, oh wait. Yeah, 2 minus x squared. It's equal to p. Okay, so I want to start by considering The absolute value of 2 minus the absolute value of x minus x squared is equal to y as a function, and attempt to graph this. So I'm going to start with the very inside part and just graph that, the absolute value of it, I guess. So x minus x squared is equal to x times 1 minus x. So it's a parabola with roots at 0 and 1, and it's facing down. So the inside looks like a normal parabola, but because it's absolute value, the outside goes like that. Okay? Ooh. Now we're going to do 2 minus this parabola here. And we're going to kind of gradually build up to this, like to the bigger function. So if you do 2 minus this, or if we take this function, do 2 minus that, it means we flip it horizontally and translate it up by 2. So it's going to look now I guess like that. Or that is the wrong concavity. Is that the right concavity? It might. I have a hard time visualizing. I think it's like that. And now we're going to take the absolute value of this again. So I'm trying to get a sense of like how the hell this thing actually looks. I kind of want to know, does it go negative? It probably doesn't matter if it goes negative, to be honest. So now if we take the absolute value of it again, these parts where it crosses over. Yeah, I don't think it matters if it goes negative again in the middle part there. If x is between 0 and 1, that's always less than 2, so I don't think it goes negative. Okay. So if we take the absolute value of this again, then these points here are going to flip up and become positive, so you get a really funky looking graph. I think it's something like this. Okay, so this is y equals 2 minus the absolute value of x minus x squared. And now they're just asking about p. This is the graph for all values of p at once, basically. But if we're taking just one value for y, then we're basically drawing a horizontal line, and we want to figure out how many intersections we can possibly get with this graph. So if we draw the line like right through here, we're getting what, 1, 2, 3, 4, 5, 6 intersections, and I think that's the best that we can do. So I think the answer is going to be 6. But AB, any zero-dimensional number corrupt? Anders, 15 watch streak. Wow, holy crap. Thank you. All right, so I guess let's actually graph this now and see if I figured it out right. Kind of an interesting problem, this one. I like it. So let's go to Desmos. Y equals absolute value of 2 minus absolute value of x minus x squared. Oh, no. Desmos, stop. You're trying to help Desmos and you're really not. Ugh. Okay, there. Oh, dude, I got it right. Um, so yeah, you can absolutely have y equals p. What? Why does it think p and x are the same thing? Okay, y equals a. No? You're not gonna give me a slider? No. Do we need a separate y? Like, do I say y sub 2 equals a? No? A equals 1? But I want it to graph a horizontal line. Y equals a. But see, now I don't know why it's doing that. Oh, wait. Oh, you're saying, okay. Do a equals 1. Oh my god. And then y equals a. There we go. Thank you. So yeah, if we take, like, say, that horizontal line there, you get 1 solution, 2 solutions, 3 solutions, 4 solutions, 5 solutions, 6. There we go. Six was an option, right? Okay, yeah, so B. Oh, do you have a third one already queued up in there? We need translation for this. Are you still here, Bio, by the way? A two-digit number that is equal to the product of the sum of its digits and the absolute value of the difference? Oh my gosh. It's hard to make this zoom in enough. A two-digit number that is equal to the product of the sum of its digits and the absolute value of the difference. Oh gosh. Type this out in chat. Hard locked. Holy crap, dude. Thank you so much for the 5 gifted. The answer is 5. You know what? There you have it. Thank you so much for that, Harlock. I really appreciate it. I don't know, like, what to say, but that thank you, I guess. Hey, Donkey. The 3-month gifted to Donkey as well? You guys are too nice. Thank you so much, Donkey, as well. Thank you, Hardlock, for gifting Donkey the 3-month sub. Wait, is it Donkey's birthday, or are you saying Donkey say happy birthday? But it's Donkey's birthday? Well, happy birthday, Donkey. I feel like I should be giving you a present, but well, it's Tuesday. Oh. Well, holy crap, dude. Thank you so much, and I guess happy belated birthday. He takes kisses? Oh, good. I was just about to ask that. And all cash should go to you? Only kisses? Yeah, thank you. I'll I'll put your kiss in the mail, donkey. I don't want to take the time to type this entire thing out, but I've already new typed it all out, so. Given two digits x and y, two-digit number that is 10x plus y with x not. Oh god. Yeah, bio. Did you miss it? Better not get import tax on my kiss. Well, that'll be your birthday surprise, donkey. Just went to grab something. Okay. Yeah. I recommend you do watch the stream because I worked out how to graph it without looking at it. You should get this for the graph of the parabola, and you basically draw a horizontal line that intersects it as many times as you can. B, yeah, I got B. So you can get 6 solutions here. And I was just working on getting the other one you posted put in there. So I did it without decimals for that exact reason. Like on the board there, like I showed it like how to figure out the graph of this, like in a couple of steps. So you can absolutely figure out how to graph this without decimals. But yeah, if you're able to rewatch the recording, that's what I recommend you do. I feel like Corrupt Converter was saying things that I kind of missed in the flood of subs there. The product of the sum of the factorial. The x. Oh, okay. You're just memeing with that. Okay. And so let me try and figure out what Anders and Corrupt are saying. Given 2 digits x and y, a 2-digit number is 10x plus y with x not 0. Right. Then the condition is 10x plus y is equal to x plus y times x minus y. Okay. All right, yeah, Corrupt is just memeing, which is fair enough. 2-digit number that's equal to the product of the sum of its... Okay, so yeah, they do give you a hint that it has to be 2 digits. And so I guess we're just solving the equation that Anders set up there. Okay. I don't know how we're going to solve that. That seems kind of hard to solve. Actually, maybe not. Let's see if we can work through it. A level 4 hype train emote. Ooh. Okay. See, I agree with the setup that Anders proposes here. So, I guess we'll say consider a two-digit number x, y. Then the number can be written as x, or sorry, 10x plus y with x not equal to 0. And as Anders says, if x equals 0, then it's a one-digit number. So the problem is to find all x, y such that this two-digit number is equal to the sum of its digits times the absolute value of the difference. This might be one where you can guess and check. Actually, it's multiple choice. So if you're doing this on a test, you could probably just get, like, guess and check. Now that I actually think about it. It's like they gave you 10, 30. So like 10, you're going to get that or like you'd set up 10 equals 1 plus 0 times the absolute value of 1 minus 0. That certainly is not true. So already A is out. I think, yeah, so that's probably not like the theoretically correct, or, you know, it's not like the rigorous way of doing it, but if you're on a test and you just need to get the answer quickly, this is the quickest way to do it, I think. Just consider each of the answers and check them. (31) is equal to 3 plus 1 times the absolute value of 3 minus 1. 4 times 2 is not 31. Isn't 31 prime? That's certainly not true. You don't think you'll do it by guess and check? It says the number is in the interval. Does it mean it's... Oh, it's not all the numbers in the interval. It's just some number in that interval. Okay, okay. I thought they were saying it'd be every number between 10 and 30, including 10 and 30. You're right, but yeah, prime numbers would... Yeah, okay, never mind. That's not a possible... Yeah, never mind. The interval stuff would not be like that because prime numbers exist. Thank you, Bio. So yeah, you're right. You maybe still could work something out based off the answer given, but you're probably just kind of stuck working with this equation. So my only idea for trying to solve this was to divide over the x plus y and then break out the absolute value. So get the absolute value, either it's equal to the positive thing, or it's equal to the negative thing. Right? And then can we isolate y somehow, or like how does this, like, now I don't know what to do again. Why are Twitch emojis so lame? I don't think they're lame. So I guess we multiply the x plus y back over in each equation. We get what? 10x plus y is equal to x squared minus y squared, or 10x plus y is equal to y squared minus x squared. Like, what do we do with this? I don't know if you really can solve. I know, like, or maybe algebra isn't even the right answer here. I kind of have to pee also. I feel like we should just manually find a number, like do an educated guess and check. I feel like that's a more practical thing to do here. You think it's combinatorics? Maybe. Yeah, dude, I gotta use the bathroom so bad. I'm gonna be right back. I'm gonna keep thinking about this one. I'm a little bit stuck right now anyway. But I'm gonna be right back. Okay. Um. Oh yeah. No, corrupt. It's not really randomized, those screenshots, are they? They're kind of all going in a row. I need to see if they somehow got unrandomized. But oh wait, are you SG1 bio? It's like, what kind of number can potentially work here? Like, I'm just trying to think about this more logically. Like, it has to be, it can't be a prime number. Yeah, I mean, quadratic's kind of rough when we have a y squared in there too. Seems like it's only one solution, Andrew says. Yeah, I mean, we only need to find one solution, I guess, for the sake of the problem. There could be multiple within the intervals as far as I know, but we don't necessarily need to care about that. So like an even number seems easy to work with. If we had like 24, what's the problem with 24? We would do 2 plus 4 is 6 times 2 is 12. So that's enough, but could we do like 48 then? Because I was nearly there, I just need to multiply it by 2. So 48 is 12 times 4. Oh, it's 48. Right? Write a Python script. I mean, that's not a bad option either. So yeah, but I feel like for this, you just guessing and checking is probably the best solution, to be honest. So I tried to think about things that like I was trying to narrow down what it could be. So prime numbers are just completely out because you can't take two numbers and multiply them to get to a prime number. And then I was thinking more about even numbers, just kind of hoping, or I think that they'll be easier to work with. Like they tend to have more factors, so you have a better chance of getting a solution. And so 24 is the first even number that came to mind that has a lot of factors. And that was only, if you do the adding the digits and multiplying by the difference, you get 12. I was like, oh, it's only half. So let's try multiplying 24 by 2 and seeing what happens, and I got 48. So it's a little bit lucky. It's probably a lot lucky, but that was the thought process that I did. I think they're way too hard for a high school student like you, Bio, yeah. I think they're too hard for, these are like competition level problems to me, to be honest. Not a super, like, not like Olympiad questions, I guess, but these are like, I would expect to see it in a competition. Integer solutions. Wait, 10? 48 doesn't work? Oh wait, no, y equals 0. Well, I mean, no, that's still, it's because Wolfram Alpha isn't interpreting it right. If x equals 10, that's 100, so no, that's out. But if y equals plus or minus 1, or if y equals 1 and x equals 0, that is 10. No? I have a, yes. No? No, neither of these are valid. We've done the quadratic and use the knowledge source allows to be an integer, and y not greater than 9. Ah! That's kind of curious, it doesn't get 4 and 8. Let's make sure I'm doing, okay, true. I wonder why Wolfram Alpha doesn't get 48 then, but yeah, I honestly, guessing and checking and just trying to figure out why your guesses don't work seems to be the best technique that I can think of with this problem. It's option C. I'm pretty sure it's option B. 48 is the answer. Unless SG1, you can think of a number that fits between 71 and 80. I can't do that. The nice thing about equilibrations is that they're essentially just surjective maps. For equilibrations, you get the map x to the absolute value of x equals the equivalence class. Given the surjective map p of x to y. Is that absolute value of x, or is that just, does that notation mean something else? Oh, that's what you do with Python code milk? The equivalence class? Oh, okay, okay. Yeah, the equivalence class of x. Oh, I see what you mean with that now. (71 times 80? Shun, I think you're misinterpreting the question. So it's 8 times 6 is 48. So 48 is the right one, but I don't know where the 78 times 80 comes from. They're asking like, because 48 is between 31 and 50, so you'd say option B there. I don't know why it will be between 71 and 80. Oh, plotting that? I see, okay. Parentheses on the mod part. Yeah, Wolfram Alpha might not like the lack of parentheses. Oh. Oh my god. Mod of x comma 10. Ooh, that's a cool looking graph. Look at that. Is it interpreting that right though? I think it's interpreting right just with the parentheses. How do you plot x on top of that? I don't remember how frickin' Wolfram Alpha works. Is it like that? There we go. Never mind. No? This corresponds between surjective maps and coincidations might be a nice thing to think about, and stuff like the functions and coincidations in the book. How do you plot Wolfram alpha? Yeah, I mean, this ones might be better for this. Yes, Yuan, I think we agree on the answer. I don't think... Like, the answer is 48. I think we agree on that. How's Desmos going to interpret this? With great difficulty. Oh, we can get rid of the plot. Translation to Desmos? Okay. Does it... Oh, we do need to make that an absolute value as well. I know if Desmos plays nice with floor. Oh, no. What's the error say? Let's see. Expected parentheses to match parentheses. That's pretty reasonable. Where do they mismatch, though? Oh. Is that it? There we go. Oh, you could drag it out, too. Okay. Oh, yeah, that's one works, but it's not a two-digit number. That's presumably not an integer. Nope. That's not an integer. Non-integer. That's the integer. 48. Oh, and then Desmos can't quite calculate everything. Actually, does it? No, just doesn't go that high up in the first place, I guess. Okay. Uh, 4x equals what? The top one or the bottom one? Or are you talking about like making this into floor x? Oh, instead of y? Okay, okay. Whoa. Uh, I don't know what it's doing, but it's sure doing something. I need to remember what surjective means again, because I was thinking about what Yanis said, but I always get surjective and injective mixed up. Expand the list to the right, like drag it. Wait, to the right. Or, oh, like this? Oh yeah, like expand this there. Oh, SG1, we're just doing some like for fun exploration right now of the same question. But the answer is 48, which I think correlates with option B. Surjective is onto. Floor the X in the mods. Oh, okay. I assume that's more in line with what you were imagining. I still don't know. It seems to get the right answer. have a hard time imagining why, but everything codomain gets mapped to. Ashwin, we don't really have another question in queue right now from, it's why I'm kind of doing this for fun exploration. Mod X10 wasn't floored, that's why it was curved and weird looking. Oh, okay. Yeah, because I guess modding with decimals, I don't know how that works. It looked cool though. I'm scrolling for just reading what Yanis is saying. Let me do hide problem. Define x is related to x prime if and only if p of x is equal to p of x prime. Oh, okay, so you can make a function that determines whether things are equivalent. And as long as you're covering everything in the codomain, then you're not breaking any equivalence relation properties. I don't know how you would solve it analytically. It looks like kind of a nightmare. I mean, it's probably easier if you do the thing that, like, what I have on the board there. I don't really know what you do with that. Okay, wait, is that a circle or an ellipse? No, it's probably a hyperbola. Solve it integrally by means of Wolfram alpha. Like, isn't this the equation of hyperbola? Like, let me give Wolfram alpha this. Like 10x plus y equals x squared minus y squared. Oh, Justin, hey! How's it going? This is hyperbola. I saw, yeah. It's the half an hour ago. Oh shoot. It was either Hardlocked or Donkey. I don't remember who's went to whose. I can't even see right now. Oh well. Well, yeah. Congratulations on the gifty though. Integer solutions. Oh, that's not right. Where did the hyperbola come from? What I was doing on the board, if you mess around, I mean, I can put it with the inequality too, or with the absolute value. But I was thinking that, like, getting the graph without the absolute value would be cleaner. I mean, let's give it the original problem too, I guess. But that was just like me when I was like playing around with what's it called? I was just like playing around with the algebra. Oh wait, yeah, we already looked at this, didn't we? You fucked something up when you wrote it down. Exponents by y minus x. It doesn't matter because it's absolute value. Or like they're both true. Oh, it might be that like if we only care about between 10 and 100 or 10 and 99, maybe you can narrow it down based on, actually no, you can't. Prove that given a surjective function p maps x to y, when I wrote x is related to x prime if and only if p of x is equal to p of x prime actually defines an equivalence relation. That, I guess that makes sense, yeah. That kind of like, I guess when you like cross-contaminate, that's not even like the right word, between different concepts, it kind of confuses me how you bridge the gap from one to the other. But I think I can like intuitively see how it's related, even though if I know I probably wouldn't be able to do the proof on my own right now, at least. I mean, since we don't have a question from chat, we could go back to some of that number theory stuff from the abstract algebra book. Like, I don't want to work ahead to the group stuff, but we can go back and do things that were already covered. What's that number system with a squared equals 0 and a not equal 0? Are you talking about what I have on the board? It's something that Andrews proposed that I agree with. If it's a 2-digit number, oh no? Okay, never mind. You're asking that in a completely separate context? Oh, never mind. What's that number system with a squared equals 0 and a squared is not equal to 0? Never mind. Is that a tessarine? Sorry, my mind was still stuck on the other one. So I want to push number theory stuff too. You're about halfway through them. Yeah, I mean, I don't want to finish number theory stuff, but it's probably good for me to do more of it. You forgot what it's called? If you square a number, it equals 0, but it's not 0 itself. A single number? I don't know what that number would be. It had like an epsilon thing or whatever that the squared equals 0 and wasn't 0? Matrix form 0, 1. Oh, excuse me. I remember doing 8. I don't know if I actually proved this. But this is like the distributive property for mods, I guess. It's not actually, or it's a bit different than distribution. A plus b epsilon, epsilon squared equals 0, epsilon's not. I've never heard of that before. Corrupt. So I assume if we're going to prove number 9 here, we're going to need that quotient form, I guess. Just going to kind of play around with it and see if something makes sense. Hey, Rolando Martinez. Actually, so yeah, before I even look at the problem that I was about to do, you're kind of busy. So do you want me to go through it now and you can go back and look at the recording on your own time? Or do you want to like check back in and chat and talk about it live? All right, see you, Corrupt. Thanks for hanging out. I have it to do either, Rolando. You're gonna watch back your stream later. You can't right now. Okay, so yeah, I'll work it out now. Just look at the timestamp, 3:20:35 ish. Actually, no, it might not be that. And I'll go and work through it, and you can look at it whenever you have time. Thank you for the question, by the way. Hope you enjoy your day. That is a good question, I guess. Graphically, you want to know why these derivatives are true. Kind of glad this takes so long to erase because I'm kind of thinking about what I'm going to say. You have a good day too, Rolando. Okay, so Rolando of the future. I'm thinking that graphing, it's probably not a very good way to, and it's certainly not a way to prove a derivative. To kind of help you remember derivatives, it's not. I kind of still am in favor of just rote memorization. But the explanation, if you really do want to do it graphically, is I'll give it my best shot here. So if you want to write like y equals e to the x first, I guess we would think about the slopes of the tangents at kind of various points throughout the graph. So like over here, when x is negative, our tangents are nearly horizontal. Which means that we'd expect the derivative to be pretty close to 0. And then as we increase as and x goes to the right, the actual slope starts increasing more and more. And the tangents themselves are going to kind of like shoot up super fast, almost the same way that like an exponential will. But I'm doing this a little bit backwards because I already know that, you know, e to the x, that the derivative of e to the x is e to the x. But, yeah, it just happens to be that, like, you know, the function that starts out, or, you know, if your functions start out really close to the 0 with the slopes, and they eventually, the slopes are basically, they're also increasing exponentially is maybe the way to think about it. Um, so I'm having a little bit hard of a time like describing it, but hey, Upshape2, thanks for the follow. So yeah, I guess it just happens to be that the slopes of the tangents are increasing exponentially as well. And for e to the x, it's like a perfect correspondence. What I don't love about this explanation is we have other types of functions that similarly blow up to infinity, but at different rates. Like a parabola, y equals x squared. So like just because our tangents here are also going, it's increasing super fast for these values of x over here, but we don't have a parabolic behavior over here. It's still just a linear behavior. So kind of drawing things, it's not 2x, but just pretend it's 2x. It's scaled weird. So just because, that's what I don't love about the graphical approach, because it's really hard to make a distinction between the parabola and the exponential. For I think something like that, you can maybe consider the entire parabola. No, it has to be something different. But that's why I'm not in love with this approach. But we can still draw some conclusions and try to remember some things from this. So I think with the trig foot functions that you mentioned, there is maybe a little bit more meaning there, or maybe not like meaning is the wrong word, but it's a little bit, I think, better of a thing to look at with trig functions. So if you have y equals sine x, here, if you look right at x equals 0, the slope of the tangent is as high as it's going to get. Sine is never increasing faster than when it's at x equals 0 or 2 pi or 4 pi or negative 2 pi, or wherever the zeros are, basically. Because every time if you're getting closer to this peak, you're leveling off, or if you get closer to that valley, you're also leveling off. So the part where you're going the fastest is halfway between those two before you start to level off in the other way. So if we come over here to the graph of our derivative, that's why at x equals 0, we start at the peak, almost like how cosine starts at the peak. And then by the time we level off here, the derivative is going to go down to 0. So cosine has its first 0 there. And then now the relationship kind of repeats from here, where we now, I guess, a minimum, because it's changing as fast as it can, but in the negative direction. And then as another peak. And then it just, I guess we'll do the entire period of cosine. It has a peak, and then it has another kind of fastest point there. So I think if you do insist on this graphical approach, it makes the most sense to me with sine and cosine to help remember things. Especially because in the other direction, if you want to start with cosine x and get negative sine x, I think this could help you remember that negative sign. Because it's the slope, it starts at 0 slope, but immediately the slopes are negative here. And that's your kind of clue that you want to have a negative sign in front of your derivative here. So we start at 0, and then we have to go down and hit a peak, and then we'll come up. And that's why we have a negative sine x for our derivative for cosine. So I think it's kind of the best thing I can come up with for this kind of graphical explanation of the derivatives. Like I said, I'm not super in love with it because of this issue up here. That's hard to express just on a a rough hand drawing. The approach that I do favor is just the rote memorization, unfortunately. Or if you want to get really serious, break out your limit definition of a derivative and actually prove these things. Or there's also another definition with f of x minus f of a over x minus a. These are equivalent, but you can prove all of these using the limit definitions if you cared to, but it's not always easy. You like those? I didn't see when you typed that, Justin. Are you talking about the derivatives that like I was graphing, or the limits, or what part? Oh yeah, the limit definition of a derivative. Yeah, you can get some really fun limits to prove when you use it. They can be kind of tricky, but I think it's still fun. They can have recalc. You enjoyed it, yeah. Because you're kind of forced to do some limits without techniques that you have in a calculus class, because you haven't necessarily proven derivatives yet. So you get like limit of sine x over x. To the one, the limit of e to the x minus 1 over x or something like that. Yeah, I think you have to prove that exact limit, and that one's a fun one to solve too. But yeah. Oh yeah. And so I was gonna. So I hope that addresses Rolano's question. I guess we won't know until Rolando has a chance to watch it back and potentially get back to me. So before Rolando asks that question, we're going to work on this question. And I lost my train of thought with it. So where would I want to take this? I was thinking I wanted to put it into, I guess, like the quotient form. So we'll say that a is equal to qn plus a prime. Don telling us to watch our back? No, if he gets us back. But also watch our back. No. See, I don't necessarily know where it's going, but I assume that's how you would do a problem like this. So let's try it. Okay. A mod n is equal to a prime. B mod n is equal to b prime. Are you hyped for this problem? Yanis, is that what that means? Or a prime plus b prime mod n, right? Oh wait, no. A plus B mod n is equal to A prime plus B prime mod n. And AB. Oh gosh, okay. We have to do it for that's right. Yeah, okay, okay. Okay. Wait. Shouldn't it be A prime mod n, B prime mod n? No? Never mind. Oh, yeah, no, never mind, never mind. I'm getting mixed up with like the A prime and B primes have already been modded. So I'm thinking that we'll break like if like A mod n being equal to A prime implies A is equal to some number, I guess I'll use my k1, k2 times n plus A prime. And B mod n equals B prime implies that B equals k2n plus B prime. So if we want to consider A plus B, we would say it's equal to k1 plus k2n plus A prime plus B prime. Now, do we need to consider I guess we need to consider what A prime plus B prime mod n is. And maybe we'll do some substitution with these two equations. So A prime plus B prime I don't know exactly what to call our constants here. Because we'll say k3n plus... This is terrible. I don't want to keep using... I'm going to say r. So I was thinking... Do we get any mileage from this in this? So A prime is equal to A minus K1. K1n and B prime is equal to B minus K2n. K3n plus R. Oh. Does this imply, are we getting equality out of this? Is that what we want? Not equality, but like... So A plus B mod n is equal to R. Does this imply A plus B mod n is still equal to R? I think I might have just done it right there. Subtract A prime plus B prime and use exercise 7. Is that what Ranger says? Oh. I wonder if I also did it in a way that would work. Let me see what, let me try and think more about what Zone Ranger said. Okay, so subtract a prime plus b prime and use exercise 7. Yeah, I assume for my a plus b equals k1 plus k2n, that's where I would think, that's where I would think to subtract a prime plus b prime. My proof is correct also? Okay. If there's a more, it sounds like this might be a more elegant way to do it though. So it's probably good to understand. A mod n equals b mod n if and only if n divides a minus b. Oh, and so, yeah, if you subtract a prime plus b prime from each side, the a prime plus b prime on the right goes away. And so, when you get that, or subtract a prime plus b prime to the other side, I guess, really. But what does that imply? Use exercise 7. If... Oh, this means that n divides those two sums, which means the mod n of those two sums are equal. Okay. That's probably a bit more concise. But yeah, we have this situation, so it implies here instead of a, it's a plus b, and instead of b, it's a prime plus b prime. And that's the proof. Okay, I probably do like that more. Okay, that's a neat way of doing it. Just remember to give out saves. Also to Yanis for agreeing with me, which I always appreciate people who agree with me. I don't care if it's right or wrong, I just want people to agree with me. So I guess let's try that with the product part of this now. I don't know if exercise 7 is going to come in handy for this. I don't feel like it will, but maybe. So AB mod n, or maybe it could. Would we want to examine AB minus A prime B prime? If we can prove that n divides it, maybe we can use exercise 7 again. Like, I just want to consider that in a vacuum. We can say that A is equal to this, B is equal to that. We need to make more constants for A prime and B prime, but I wonder... So 7 will work on the second part? Okay, good to know. So I assume we kind of have to force it to happen by doing something like this and hoping it divides n. So A is k1n plus A prime, we said. B is k2n plus B prime minus... This foiling is going to get a little tricky. I guess we're gonna have to hope the constant terms cancel. This is... Those definitely aren't gonna cancel. I would want the A prime, the B prime, the R1, and the R2 to cancel out somehow. That's not gonna happen though. Stay with A. Oh, you're right. We don't have to sub the A prime and the B prime. Okay. Now, yeah, that'll definitely cancel. K1, K2, n squared plus B prime K1 n plus A prime K2 n. These will, as long as they all have an n, they don't really matter. But then we'll get A prime B prime minus A prime B prime. So actually, I don't have to write anything else. So yeah, okay, so n. That means we can factor out an n. That one there now. Plus A prime K2 n. So that means AB minus A prime B prime divides n. Or n, reverse it. N divides these two, which implies AB mod n equals A prime B prime mod n, exercise 7. Okay. That's a nice problem. Let's look for another one to do. I don't know if we're going to go down the line for all of these. Just kind of take a look at the next few and see if one appeals. So we just did 9, so it's 10. A and B be positive integers. D equals GCD AB. M equals LCM. T divides A and B. Prove that T divides D. Okay. So the greatest common divisor is a multiple of any other common divisor, I guess is another way of saying that second sentence. Then if S is a multiple of both A and B, then S is a multiple of M. Okay. So any common multiple is a multiple of the least common multiple. So we're going to want to go to our linear combination for the GCD. And then do some kind of sub with T times a constant. Oh, I think that's the entire proof for the GCD part. You make it a linear combination, you plug in t times a constant for a and b, and then you can factor the t out in t divides d. How are we going to do the least common multiple part? Because the least common multiple isn't necessarily a linear combination. Right, like the least common multiple I usually struggle a bit more with too because it doesn't have that nice other form we can write it in. You definitely write it as something times a and something times b. It's just not necessarily a plus b unless they're relatively prime, right? Or a times b. So maybe the prime factorizations are going to be involved. I feel like it's a little quiet now. Turn it up a tiny bit. If S is a multiple of both A and B, prove that S is a multiple of M. All right, I'm gonna have to play around with that one for the least common multiple part. Actually, wait. Do we have anything up above that has to do with LCM? Hey, Muskin Kumari, how's it going? We do have this. That might come in handy. LCM is AB over GCD. Maybe. I don't know if it will. You're going to sleep now? Oh, if you wanted to actually try it, I didn't realize that. I thought you were just kind of saying that for fun. But I can try it. Or maybe I'll do it the next time that you're around. But I hope you have a good night, Yanis. So I think the first part of this proof is going to be like 2 lines or something. The second part of the proof, it might be 2 lines and I just don't see it. I'm not really sure yet. Who's that? Med U vacuum? I'm probably saying that horribly wrong, but thank you for the follow. Okay. So what do we have here? A and B, positive integers. D is their GCD. M is their LCM. So if T divides A and T divides B, then T divides D. Start with that. Okay. So, T divides A implies that A is equal to some constant times T, and that B is equal to some other constant times T. So now let's examine D and know that it's the GCD of A comma B, which means that it can be written as a linear combination of A and B. We already used T. I guess we'll say R and S. Oh yeah, we get our BS again. So we have D is equal to AR plus BS, but we know that A is equal to K1 times T. Wait, what the heck am I? K1 TR, and B is equal to K2 TS. Factor the T out. K1 plus K2S, K1R. Which, since D is equal to T times something, that implies T divides B, or T divides D, as required. Box. We also want to prove that if S is a multiple of A and B, A divides S and B divides S. Oh, well, I don't know, so we'd use S later on here. That S is a multiple of M, that M divides S. So this is the only thing I can think to use of. Or the LCM is equal to AB over GCD. AB. And after this, I didn't know what to do. I was hoping to figure it out now. So can we make a similar thing as up here? And we're gonna get some fractions now, but that'll be okay since if we're working with integers. No, it might not be okay. Okay, if we want to show that M divides S, it means When in doubt, you fall back to the fundamental theorem of arithmetic. Oh, like looking at the prime factorizations. I think you talked about doing it a proof method for like to prove like this relationship here. I think, which I think that's what the book actually did. But I feel like we shouldn't have to use that. I think what I want to do. Let's maybe rephrase this a little. D is the GCD, so we can say dm is equal to AB. And if A divides S and B divides S, then all I can think to do is to say that S is or A is equal to S over something, K1, let's call it. And that B is equal to, well, do we need them both? Maybe we only want one of them to be subbed. This S squared seems a little weird to work with. Can we verify if we isolate, wait, M divides S. So dk1m over B is equal to S. If we can prove that dk1 over B is an integer, I think we're done. So I guess let's think about well, D is a divisor of B. And K1 we really don't know much about. S is equal to MQ plus R. Oh, really? It's equal to MQ, starting with that. And you're saying to isolate R to S minus MQ. And 0 is less than or equal to R is less than M. By definition. AB divides S and AB divides M. AB divides S and AB divides M. Wait, AB divides M. Oh, wait, AB divides M because it's the least common multiple. How's it showing that M divides S? AB. Hey, Anders. A and B divide R. But M is the LCM of A and B. Oh gosh. Okay. A and B divide S and A and B divide M. Right. A and B divided S were given. A and B divided M is by definition of LCM. Which I guess I can see how that would imply that A and B divide R? But M is the LCM of A and B, hence R equals 0. Oh God. A and B divide 0? I guess there's no reason why you can't do that. Okay. Because 0 times a constant? Okay. This S equals MQ. Huh. Okay. So AB divide S and AB divide M imply that A and B divides R? And then this is the part where M is the LCM of A and B, which means R has to be 0. That's where I'm still trying to figure out. S has to equal MQ. Or rather, oh, okay. This is implying that if you divide a number by something with A and B in common, actually, no, I feel like I'm maybe like 50% of the way there. R is the remainder, so it must be 0, otherwise Q was the wrong Q. M is the smallest positive number such that A divides M and B divides M, and R is less than M. Okay, yeah, R... Okay. I feel like this one's going to need to sit for a little bit before it really sinks in. But I think I get kind of the idea. Because... God, okay, that one's gonna have to marinate for why exactly that works, but I think I understand like kind of what you guys are getting at. So I can say that R must be 0. Because R has to be between 0 and M. And M being the LCM. Kind of forces that. Yeah, A and B divide S. A and B divide M. A and B divide R. But if they divide R, it must be 0. R is a common multiple of A and B, but it can't be the LCM since M is. Oh, okay, and so where it's getting tripped up is why can't R just be more than the LCM, but 0 is less than R is less than M? Okay. I think that makes sense now. Prime decomposition proof is better. Ugh. I feel like that's using a hammer for everything milk. Okay. Um, thank you for the explanation zone. Um, don't do that. Do that. Actually, I guess we have been just going down the list, haven't we? Okay, let n and a be positive integers, and let d equals GCD of a comma n. Ax mod n equals 1 as solution if and only if d equals 1. What? Let me fix the screen capture a little bit there. I don't like that. A little bit is cut off. Okay. And they be positive integers. If their GCD is 1, they're relatively prime. Yeah, I guess any multiple of a. I assume x is an integer. Or it has a solution if and oh, okay, yeah, fair. So if you take a relatively prime integer, or you take two relatively prime integers and you mod them, do you always get 1? Is that what what part of this is saying? Or it's I guess like from right to left. How does that work? If you take, say, 6 and 5, you do 6 mod 5, you do get 1. You do 12 mod 5. Isn't that 2? Oh no, it has a solution. It doesn't have to be. I think it's not for all x, just that there is an x. So I think, Milk, your example, 5 mod 3 is 2. You should be able to find some multiple of 5, though, where you get 1. It said there'll never be 1 if they're not relatively prime, I guess. So you could say 10 mod 3 is 1. So, okay, let's try it if they're not relatively prime. So if you have 12 mod 3, I guess that's forced to always be 0. That's not a good example. 6 and 8, that's probably a better example to use. So 8 mod 6 is 2. And then no matter how we multiply 8, we're never going to get 1. Which I guess that makes sense. If they're even numbers, they're going to be forced to be at least 2 apart. I guess I can kind of wrap my head around why this works. I would never have guessed this. Like, okay, so I'm glad that we did some examples because like I was thinking it was like for all x, but that's certainly not the case. Just there exists an x. If they share 3 as a factor, they're forced to always be 3 apart. I think that's the idea, Milk. Like, or like I guess at least 3. Goodbye, marker. Wait, so we have a and n as positive integers? N and n plus 1 are always relatively prime? Yeah, that's kind of what I was going through my head too. Wait, sorry, I'm looking at the wrong one. N and a be positive integers. Okay, and so we want to show that there exists an x such that ax mod n is equal to 1 if and only if b is equal to 1. That's how I would characterize, I guess, this question. So I think, what direction do I want to try first? I think maybe from left to right, it feels like we have more to work with this. So if we get to accept that this is a fact and try to get that they're relatively prime, what would that look like? Oh, wait. That's a linear combination. Okay, well, that was easy, wasn't it? uh, do we just do the reverse now? I don't think we did any one-way steps. Uh, Cockroaches, Anders? Oh, God. All right. Let me just do the reverse part of this proof, I guess, and then we'll draw some cockroaches. Okay, so d equals 1 implies that we could even reuse our letters here. implies that there exists numbers x and m such that ax plus mn is equal to 1. And then you just kind of casually subtract the mn over. So ax mod n is equal to 1 for some x. Okay, that proves not as bad as I thought it'd be. All right. We want some cockroaches, Anders? I don't like cockroaches. In an apartment in my second year of university with roommates, had a cockroach problem, and it was not pretty. The landlord wouldn't do anything about it either. And, you know, if we're gonna draw cockroaches, we're gonna draw the big fat ones, right? I think they have 6 legs. Little antenna. Little like they're like wing flaps. I think they have like a little like mouth too, like that. I'm gonna draw them like that. Actually, I can look at the emote. You know, that's a good like reference. That's a tick. What? It does look like a tick too. You're right. Okay, here, look. We even draw. Well, he said cockroaches, so we'll draw multiple, and some will be flying, and hopefully that conveys cockroachness. How does a cockroach look when it flies? Wow. I don't know. They do have like little like things on their wings, right? That go like I think like that. I kind of make it look like a bumblebee now. You know, they have long antennas. All right, I can make them longer. I mean, what is a cockroach if not a bee and a tick combined, though, you know? I feel like we should get at least a third one in here, you know? I don't like cheap out on the cockroach for Dean. What should I draw it on, though? Right? Like, maybe we'll have a cockroach that's like I wish I had yellow. I guess the yellow looked kind of weird. So cockroaches eating a piece of cheese, you know? Cheese will be red because you know who likes blue cheese. Ha, get it? There we go. I feel like that's not a bad cockroach right there, right? I don't know. You like it? All right, I'm glad. Show that 5n plus 3 and 7n plus 4 are relatively prime for all n. Do you take the mod n? That feels kind of weird. I assume that's what you have to do, though. And use some of the facts that we proved earlier with sums and products of mods. So what do we have again? 5n plus 3 and 7n plus 4. Okay. So let's, I guess, look at them both mod n and hope we get no overlap. I mean, that's just going to be 3. Because 5n is always 0 mod n. Oh, is that actually all you need? I mean, I can justify that more, but one is 3 mod n, one is 4 mod n, so they can't possibly be the same number. Like, mods are a little bit weird to me because my impression of mods is they're not good for proving things are exactly equal to each other. But they are good for proving things aren't equal to each other. Sure, as long as n is greater than 4. Okay. Why isn't it generally true? So I was thinking that, like, it didn't really show, but I was thinking, like, 5n mod n plus 3 mod. Like, do these identities, like, put any qualifications on a... Oh, I guess the 3 mod n part is... That's... Okay, that's fair. I'm assuming n is greater than 4, or equal to 4 there. Okay, so it's not quite as simple as I'm making it. So how do we deal with it for, 0, 1, 2, 3, 4 and negative numbers? Seven times 3 plus 5 times 4 equals 1. Seven times 3 plus 5 times 4. Oh, minus 5 times 4 equals 1. Showing the GCD is 1 would do the job. I don't get how we construct that, though. Seven times 5n plus 3 minus 5 times 7n plus 4 equals 1. Oh, so you've taken a linear combination of the two numbers and found one that's equal to 1? Huh. Wait, so is the GCD, is it every linear combination? Like, because as far as I know, those numbers, I mean, well, they chose them for a reason to give cancellations, but like, is the GCD, it just means there's a particular pair. How do we know that that particular pair is right? Smallest possible integer that is a linear combination. Can get a linear combination to be equal to 1, so the GCD is less than or equal to 1, so it must be 1. Oh, the smallest. Oh, okay. So if their GCD isn't 1, you would never be able to get a GCD of 1. Okay. Fair enough. I don't think the book even talks about that fact, so that's good to know. I don't have a ton more problems left in me, but maybe let's look at 1 or 2 more. Suppose m and n are relatively prime, and r is any integer. Show their integers x and y. Wasn't r equal 1? Is this a proof that they said, like, you know... Okay, well, I want to scroll back and see if they said that we'll prove this later in the actual chapter. Oh, I guess... Okay, that's fair milk. So 13. Oh, I see. You just did the proof right there, Milk. I get it. Okay. So, okay, this is what this is actually saying is that you can make, if you have two relatively prime integers, you can make any other integer with a linear combination of those two numbers. And Milk just proves it using different letters. But if they're relatively prime, you know that there exists an x and a y, such that it's, or no, I shouldn't use the same letters. You know, an a and a b, such that am plus bd is equal to 1. You just multiply both sides of the equation by the desired integer r, and you have your new coefficients. Okay, nice, Milk. Let p, q, and r be primes other than 3. Show that p squared plus q squared plus 3 divides p skewed. P skewed. P underwent a linear transformation that's now skewed. Let p, q, and r be primes other than 3. Show that 3 divides p squared plus q squared plus r squared. This feels like the trick that Bo taught me, where every square number only has so many possibilities, mod 3. Or mod, they usually only have so many possibilities for a certain mod. I mean, every number is 0, 1, 2, or 3 mod 3. Maybe that won't be enough. You might need something more here. Primes other than 3. Well, it'll never be 0 mod 3. Did I say it would be 3 mod 3? That doesn't make sense, but 0, 1, or 2 mod 3. We can eliminate 0 as a case, certainly. Don't we need him? Oh, I guess we'll have to show that it wraps back, or like they're gonna somehow, the mods are gonna add to a multiple of 3. I guess. Let's see. Ooh. Okay, fine. Go over there. Ah! There we go. Headphone cord snag. Was it PQR? Yeah. Oops. So let's take p squared plus q squared plus r squared and mod it with 3. We want to show that's going to be equal to 0, but we can't just say that. So let's look at p squared mod 3 plus q squared mod 3 plus r squared. 3 mod 3. So if you're mod 3, you can only ever be 0, 1, or 2. We can't be 0, because that would imply, since these are prime, that they're just 3. So these are all only 1 or 2 mod 3. And I think we're going to have to show these are either all 1 mod 3 or all 2 mod 3. Because any other combination, you don't get... If you get 3 or 6, then 3 or 6 mod 3 will be 0, and that's what we want. And if you don't have 3 or 6, then you're done for. Right, Milk. So I assume we're going to have to use the fact that there's squares here. We can... It's not really a proof, but we can look at primes mod 3, or prime square mod 3, I guess, and see what the answer should be. So I assume it's going to always be the same thing. Otherwise, this thing just doesn't work. So if our prime number, we don't want 3, so the next one is 5, 25. 25 mod 3 is 1. So we expected everything to be 1. 1. Okay, yeah. So we're expecting all 1s for these, but like that's not really a proof what I just did. I don't know how you would prove that. A prime number p squared is equal to some 3 times some number plus 1. Oh. Okay. I'm just going to conveniently notice that a prime number squared... Oh, wait, no, m isn't prime. We don't know that m is prime or not. Never mind. Well, I'm trying to like prove that existence. I don't know if that's the spirit of the question, but I know that we can just say that all these are going to be 1 mod 3, but I feel like we haven't actually shown that. My idea was to conveniently notice that p squared and 3 times some prime number are relatively prime, so they should be equal to 1. But we don't know anything about m. M is just whatever it needs to be to multiply to p. Unless we want a name. Oh, wait. We do have... Well, then we're narrowing our cases, aren't we? No, I don't know if that's the... It could be something like that, but... I could just be lazy and say this is my proof. Proof by 3 examples. It's just justifying going from this step to this step. That's sketchy. Can you prove it by induction? Like, I guess the claim is that p squared is equal to 3 m plus 1. And I guess our base case is 5. 3 times 8 plus 1. I don't know if does induction work with primes? I don't think it does. Never mind. But p equals 3q plus r. With 0 is less than r is less than 3. Oh. Oh. Oh, interesting, Anders. So you take just p, divide it with 3. And then you square it, and we already know it can't be 0. It can't be 2 because when you square it, you'll get 4, and that breaks the rule of R. Well, if you square each side of that equation, does the restriction on R hold? Or would you say 0 is less than R is less than 9? Or 4, which is also 1. Oh, okay. There we go. So it can be 2. Okay. I was like... Okay. That's a nice way of saying it, Anders. Hey, SPQ. Existence saying 3n plus 1 squared. 9n squared plus 6n plus 1. Okay. Odd square is not divisible. Do we know that 3n plus 1 is a prime, though? I feel like that's kind of presupposing the thing you want to prove is true. Because you already know that a prime is equal to 3n plus 1, then the work is done. Or you, oh wait, you're just taking, never mind. I guess that covers it. Yeah, every integer can be expressed. We know it's not a multiple of 3, and you can express every integer as then a multiple of 3 plus 1 or plus 2, so you're always covering it. Okay. I think that's actually basically what Anders did, but we actually plugged in 1 and 2 for R there. But a different way of like saying the same thing. That's nice though. I think I am getting towards my limit of math for the day though. Trivial kappa. Oh, it doesn't like the input. Yeah, I prefer my proof by just writing 3 examples down and assuming that it's always true. Proof by lazy induction. I see that Dan's live. So maybe let's go say hi to Dan. /raid Danny boy. Oh shoot, let me turn the YouTube stream off. Bye YouTube, thanks for hanging out.